Hey guys, in today's video, you can learn about the NestJS Authentication along with implementing an OTP email verification system and a secure forgot or reset password flow for safe password resets. Before we dive into the code, let's first see a quick demo of how the authentication system works. This is the API route for registering the user. In the post body, we need to provide email and password. So let me enter my email and set a password. On sending this request, we receive a success message, user created successfully. Along with this, an OTP is sent to verify the account. In our database, you can see the new user details with the password stored in hashed form. The account is currently unverified. Now checking our registered email, we have received an OTP for verification. This OTP is required to verify the account. Let's try logging in with the email and password. This is our login route and we can provide the email and password. If I enter an incorrect password, we get an invalid credentials error. Now let's proceed with the correct password. You can see that we get an account not verified message, meaning we must verify using OTP first. So let me copy this OTP from my email and include here. First, I'll try with the wrong OTP. And as expected, we get an invalid OTP message. With correct OTP, you can see we receive an access token along with user details. This means the account has been successfully verified. Checking the database, the account status has changed to verified. Now logging in again does not require OTP anymore. We simply get the access token. Additionally, we have a resend OTP route. This is useful if a user fails to verify their account within 5 minutes, as OTP expires in 5 minutes. Calling this API sends a new OTP to the email. So with this, we can again get a fresh new OTP, as you can see in our email also. That was for the verifying account. If a user forgets their password, they can request a password reset by calling the Forgot Password API with their email. They receive a password reset link. Since we haven't built a front end yet, clicking this reset link does not load a UI. Instead, it returns an error. This happens because there is no front end route handling this URL. So to reset the password manually, copy the token from the URL. In this reset password API, we just need to pass this token and also the new password. The reset link expires after 15 minutes, so we must verify reset token before that time. And in case of invalid token, we get invalid token message. So token should be valid. And now we have password reset successful message. So let's try again in login. You can see the previous password is no longer valid. And we must replace with the new created password. And yeah, we are again able to authenticate with the new password. Finally, we have the authentication for protected routes. For example, the /profile route is protected. If we call this API without authorization, we get an unauthorized error. To assess it, we need to pass the Jwt token generated after the authentication in the bearer token header. Once included, we can successfully access the profile with user details. So that's the full authentication flow. Now that we have seen it in action, let's break it down step by step and start implementing the code. We have already implemented the node mailer service in our NestJS project, so there is no need to recreate it. You can watch that video and directly implement the Nest authentication flow in the same project. I have also provided the link of that video on my description below, or you can also directly get that source code from my GitHub. So this is the node mailer NestJS project. Now we can rename it to NestJS Auth. Here the email.service.ts contains our email system functionality where we have implemented email service using NodeMailer and Gmail. We had also created our DTO, and this .env contains the credentials required for the email. I had also explained you how you can generate app password for your sender email in that NodeMailer video. So let's continue with our authentication part. So we should also connect NestJS with database. For database, we will be using PostgreSQL with typeorm. So let's first install typeorm and NestJS typeorm. For the PostgreSQL driver, it would be npm install pg. Make sure you have PostgreSQL installed on your system. We have our installed packages. We will be setting our database connection on inputs of app module. The typeorm module.forRoot async method is useful when you need to load database configuration dynamically, such as from environment variables or a configuration service. Inside this, we will be importing config module. For dynamic database configuration, we can use factory here. Now let's include the parameter for PostgreSQL. So here the type would be Postgres. For the rest parameters, let's include in our .env. For local DB, host can be localhost. 5432 will be the default port. Then provide your database name, username and password. Now simply access these using config service.get. Here plus sign converts string to number. For the remaining field also, let's fetch using config service. The entities will simply contain the entity for our project. We can set it later after we create the entity. The synchronized true will automatically update the entities to the table. We can set it true for now, but in production this should be false. So don't enable this while in production. Finally, we need to inject the config service. So that's all for the PostgreSQL configuration. Now let's create new folder user, and this will also contain entity. Inside this we can create user.entity.ts. This will contain the needed field for our database. For ID, we can use primaries generated column. Let's import it from typeorm. This decorator marks the ID field as the primary key for the user entity. Let's use column decorator for email. An unique true option means that the email field must be unique across all users. Let's add the password field. Then finally include the account status. So by default it will be unverified. Back in our app module, let's create user inside the entities. We can also check these fields in pgadmin. We don't need to manually create the table in pgadmin since we have provided synchronize to true. First, let's run our project. You can see our Nest server is started. Let's open our pgadmin. So include your password for your database. Inside the schema, we have the table user. And if we view it, we can see the columns of added fields. To reset the password also, first we need to have the user's email and password created in our database. So we can also create functionality for creating the user first. Inside the user folder, let's create user.service.ts. Then import inject table. This should be our user service class. And inside the constructor, we can inject our user repository. That is the user entity which we had created earlier. Before creating register functionality, let's first create our DTO. So inside the DTO folder, let's create user.dto.ts. We will be using class validator. For that, we need to npm install class validator. Let's import each string and each email decorator from the class validator. This would be our user DTO. For the user DTO, we need to provide email and password field. Each string decorator ensures that the value is a string, and each email validates that the string is a valid email format. For password, we can use each string decorator. So that's all for our user DTO. Now simply pass the user DTO in the register part. Then we can extract the email and password from the DTO. Before creating a new user, we must ensure the email isn't already registered. If we find a user, we throw a bad request exception to notify the client. In order to store as password, we need to first install bcrypt. So let's first npm install bcrypt.js and types bcrypt.js. Now we can import it. Here bcrypt.gensalt generates a random salt to add extra security to the password hashing process. After generating the salt, we pass it into the bcrypt.hash. This ensures our password is securely hashed before saving it to the database. Now we create a new user entity. The create method initializes new user object. Finally, we save it to the database. So we completed the register functionality. Now let's create controller and module for the service. The controller decorator defines this class as a controller for handling HTTP requests. We are going to start this with localhost/user. We inject user service in the constructor to use its method inside the controller. This will be our post request. We can set its endpoint to register. For the request body, include the user DTO. Then we need to call the register method from the user service. If everything goes well, the API responds with the success message of user creation. Now let's complete the module part. First, let's import the module decorator. Inside the module, we need to import our user entity. This is needed for interacting with user table. Then include the user service inside the providers and exports. The controller will contain the user controller. Finally, let's export our user module. Back in our app module, let's import our user module. Include the user module in our imports part of this app module. Now we can run our server using npm start. So let's test this register part in our Postman. The route for this API is simply localhost/user/register. Open your Postman. I will name this collection to NestJS Auth. This would be our post request. In this request, let's include our route path. Inside the body, I will provide email to jack@gmail.com and also the password. After we send this request, we have the user created message, and in our users table, you can see we have the data registered for Jack with the hashed password. So instead of original password, the password is in hashed form. Initially, our account status is unverified. We will update this to verified after validation from OTP. But for now, we just have completed the register part of the authentication. After completing the OTP email, we will also proceed to the login authentication part. First, let's complete the OTP verification after registration. So let's create OTP folder inside SRC. This will contain the otp.entity.ts. Include the entity decorator. This is our unique identifier for each OTP record. In our case, one user can have multiple tokens for different purpose like login verification and password reset. So we define a many-to-one relationship between OTPs and users. Join column is used to specify that this column is the foreign key, linking the OTP table to the user table. This also creates a user ID column in the OTP table, linking it to the user entity. Also include nullable to false here, since an OTP cannot exist without user. We will also define column token. It will simply be the hashed OTP for email verification. To create the type for OTP, let's create new folder type. Inside this, create OTP type.ts. This is an enum that helps us define the type of OTPs we are handling in our system. Instead of using plain strings, we use enum to make our code more structured and readable. So this OTP is used for login verification, and reset link is used when a user requests a password reset. Let's import our OTP type enum. Now the type column in the database can only have values OTP or reset password. This column defines when the OTP will expire. We can use create date column from typeorm that automatically stores when the OTP was created. So that's all for the OTP entity. Then let's create our service file, that is otp.service.ts. Here we will be creating our OTP generation functionality. This would be our OTP service. Inside the constructor, let's inject our OTP repository. We can name the function to generate OTP. For the params, let's pass the user ID. For generating OTP, we will be using crypto. So let's import it. Then simply generate the 6-digit OTP using crypto.randomInt. Here 100,000 is the minimum number, representing the smallest 6-digit number, and other one is the maximum number, the largest possible 6-digit number. Let's also import bcrypt. Once we generate the OTP, we will hash it using bcrypt to store it securely in the database. Also include argument type here. It is of type OTP type, which is an enum. Now we set the expiration time for the OTP, making it valid for a limited period. This ensures that the OTP expires after 5 minutes protecting users from using outdated tokens. Now we create a new OTP entry and associate it with the user. Here, instead of just passing the user ID, we can pass the entire user entity directly. Now inside this, we can include user. We don't need to manually set user ID. Typeorm handles it for us because of the many-to-one relationship between OTP and user. Let's include remaining field, that is token will contain the hashed OTP. Then we have the type and expire set. Finally save it in the database. Now we will return the plain OTP. It's because it will be sent to email for verification. Let's quickly complete the module part also. This part registers the OTP entity with type ORM, enabling database operations inside the OTP service. Then include the OTP service inside the providers. Then in the app module, import the OTP module. Also include the OTP in the entities. And finally the OTP module in the imports. Now we need to make a slight changes in user.service. Let's import OTP service and inject it here. Now we will return the generate OTP function from the OTP service. So pass the new user and also the OTP type from the enum. Since this is the OTP service, we will include the OTP value. So it would be OTP type.OTP. Since there are two arguments in return type, we should also add OTP type to the promise. So the result from our generate OTP function will be our plain OTP. Then let's return our new user with the OTP. Then we can start our project. You can see we are getting issue. It's pointing in the model. I guess we forgot to import OTP module in our user module. Yeah, import the OTP module in the imports. And also in the OTP module, provide OTP service in the exports as we are using its service in user. Now let's again run our project. So now Nest is successfully started with no issue. If we move to our PG admin, you can see we have new table OTP with all the fields included in the OTP entity. We also have the user ID, though not explicitly defined. It is automatically generated by typeorm because of the many-to-one relationship with the user entity. Now we will check again in Postman. Before that, comment this user created message, since we are gonna check if we are able to retrieve the OTP or not. If I try to register with the same email, we get email already exists. So email should be unique. Now if I send the request, you can see we have the user info along with the OTP of length 6. So that's it. Now we just need to pass the OTP in the form of email. In OTP table also, you can see we have the user's OTP info, but here the OTP is in hashed form. So we managed to encrypt this. We also have the created and expired date of the token, and finally the user ID of the registered user. So let's connect the OTP generation with email. Now in the user service, in the register function, below this OTP, let's create email DTO. The recipients would simply be the registered email. For subject, we can include OTP for verification. Inside this HTML, let's provide text mentioning their OTP. They should use this OTP to verify their account. Now in our user module, let's include the email module in our imports. Then inject the email service in the user service. Now to send OTP via email, remove this and include the send mail function from the email service. Then pass the email DTO inside this. Now modify this promise return type to void. You can see we are facing issue while sending email DTO. Recipient's value should be in array format as we have allowed multiple email also. Now it's fixed. Now after the new registration, the OTP will be generated and send this to the send mail function, which sends the email to the registered Gmail account. Back in our user controller, uncomment this and remove return from here. We can also extend this message with OTP sent to mail. And in our email module, add email service to exports. Let's run our project. Now I will provide my new email and password. So we have the success message. Let me go to my Gmail account. You can see this is my Gmail account. We have the inbox here. You can see in the text message we have received the OTP code. So everything is working perfectly for receiving OTP via email. That completes the user registration process with the OTP delivery. Now we just need to verify the OTP to mark the user account as verified. OTP verification will happen during the user login process. So first let's proceed with implementing the login functionality, which will also include Jwt Authentication. Before implementing login, let's also structure our OTP generation and email DTO process so that it can be reused for other functions as well. Right now we have included it inside the registration function, but it's more standard to keep it separate. So let's refactor it. We will be reusing this function for reset password also. We can name it to email verification. It will simply take in the user entity and an OTP type. Then just copy this part from here and paste it inside this. Now this will be user and this would be user.email. Now finally call this function in register part. Then pass the new user and OTP value from the enum. Here it should be small OTP type only. So we have only separated the OTP and email function, but the functionality remains the same as in the previous code. Now for login, let's create auth folder with its service. Let's also create login DTO. Import the required decorator from class validator. The email and password column will be the same as the register part. This will also contain the OTP, which would be optional. Now let's implement our auth service. In this function, first we will complete the general login implementation with Jwt. Then we can proceed on OTP verification. This would be class auth service. Now implement the login function. Pass the login DTO. To check if the user exists, first let's inject our user repository. Before this, also extract the email password and OTP from DTO. We can use find one method to check if the user exists. In case of no user, provide error message of email doesn't exist. Now to compare the hashed password with the plain text password, we need bcrypt. So let's import bcrypt. We can then use bcrypt.compare to perform the comparison. In case of invalid password, we can provide message of invalid credentials. Now for the JWT part, we need to import some necessary modules. So let's first complete the module setup by creating auth.module.ts. Let's use typeorm module for feature to interact the user entity in the imports. Then include auth service in the providers. Before we can import and use the JWT module, we first need to install it by running npm install NestJS JWT. Then import the JWT module. We set up JWT using JWT module.register async. We are injecting the config service to pull out the JWT secret and sign in options like expires in. For the secret key, we can currently use a simple value, but in production, it's better to generate a strong key using cryptographic methods. For now in development, I will set the JWT secret to demo secret key, but make sure to use a strong secure key in production. Using config service.get, we can fetch JWT secret, that is the secret key from .env. We have set expiry to 1 hour. After that, the token will expire and the user would need to log in again or refresh their token. Finally, let's export the auth module. Back in our auth service, let's import JWT service from NestJS JWT. Then we can inject the JWT service. Let's include the user's ID and email in the payload. Then we sign the payload using a secret key to generate a JWT token. The generated access token will be sent to the client and used for authentication in subsequent request. Finally, we return the access token along with the user's information. This is the general login flow for token-based authentication. Then let's complete the catch part. Then create the controller for it. First, let's import required service and DTO to be used in this controller. Then inject the auth service. Let's include the endpoint to login. Then include the login DTO in the body. And we can return our login functionality. So we set up the controller for it too. Now it's time to include the auth in our root app module. Then include this controller in the auth module too. Let's start the project. Now in the new request, we can set the route for our login part. Let's include this registered email and password. So if I include the wrong password, we get login failed. In the catch block, I will handle the unexpected error separately. If the error is an unauthorized exception, I will rethrow it to maintain its original message. Now if I send this request, we are able to retrieve specific message of invalid credential. So make sure to provide correct credentials of your account. On successful login, we receive a success response containing the access token along with the user details. This JWT allows user to access protected routes securely. This is the general flow of Jwt authentication. Later, we will also implement Jwt access token verification, which completes the NestJS authentication process. But before that, let's first complete the OTP functionality, as we also need to verify the user's OTP during login to ensure their account is verified. Back in our auth service, we can check for verification here. If the account is unverified, we check whether the OTP is provided. If OTP is missing, we return a message indicating that OTP is required to verify the account. Make sure your project is started. So currently this user is unverified. If I send without OTP, now you can see we have message to provide OTP. Now if the account is unverified and user sends OTP, then we need to check and verify that OTP. So in otp.service.ts, let's create validate OTP functionality, which will take the user with their OTP. First, we need to check if the OTP from the OTP repository has expired or not. We will match the past user ID with one in the database. Actually, this should be number instead of string. And this checks whether if expired date of the OTP is more than the present date. In case of date already expired, we can simply throw message of OTP expired. If OTP is not expired, then we can match the OTP. Since in database OTP is in hash form, we should use bitweb.compare. Change this naming of OTP to token, since we will be later comparing reset link for forgot password also. In case of invalid OTP, we can provide message in the error. If the OTP is valid and the user passes all checks, the function returns true. This signifies that the OTP was valid and can proceed with the next steps. So that's all for validating OTP. Now the next step would be verifying user account. In auth service, let's create verified token function which would be responsible for verifying user account if the validate OTP function is success. Now since we are gonna use the function from OTP service, let's also import OTP module in our auth module. Then inject the OTP service in auth service. Now in validate OTP, pass the user ID and token. So token here is simply the OTP passed during login. After valid OTP, we need to update the account status. So first let's fetch the user. Now simply update the account status to verified. Finally save this in database. Now we just need to call this function. This would be called if the user is unverified but provides OTP to verify their account. If the OTP is successfully verified, the subsequent part of the code will generate and sign a Jwt token. And in this catch block include bad request exception also. So here let me add OTP. During the registration time, we have received this OTP. So I will just copy and paste it here. This must be expired since we had set the expiration time of 5 minutes. If I send this request, you can see we have the OTP expiration message. So now the new OTP is required. For that we can create a controller to resend OTP. We don't need to rewrite the function as the existing email verification functionality can be utilized by defining an appropriate route in the controller. Let's create request token DTO. I can simply include that of user DTO, but it doesn't require password. This would be request token DTO. Now create post request for requesting OTP. We also need to compare email with the email in the database. To do this, we will create find user by email method inside the user.service.ts, which will search for the user by email. Then call this in our controller. If the user exists, we will generate and send an OTP. For that, let's call email verification function. Then on success mail, we can return OTP send message. We need to now slightly modify our generate OTP function. Since we have already updated the database with an OTP and expiry time for a particular user after registration, we need to check if an OTP of the given type already exists. So we can check with the user ID and OTP type. If an OTP is found, we update the hashed OTP and expiry time, ensuring the user always has the latest OTP and its validity period. Then we save the updated record in the database. Actually, this should be semicolon instead of comma. If no OTP exists for the user, we create a new OTP entity as before. So for already existing OTP, we have just updated the value, otherwise new entity will be created. Here this token part and expiry time of the requested user will be updated. Let me add new request, and the route path will be /user/request OTP. We just need to pass email in our body. So we have the OTP send message. We also have the new OTP in our Gmail. In our DB, if I refresh this, so we have the new token and expiry time is also updated. If I provide wrong OTP, then it performs checks in the DB, and you can see we have the response of invalid OTP. So make sure to provide correct OTP. Yeah, we are able to authenticate the user. We have the access token with the user's info. So this account should be verified now. If we go to the users table and refresh this, you can see we have the account status verified for Sarah Doe. Now since the account for Sarah is verified, there is no need to provide OTP to authenticate. Without OTP also, you can see we are able to retrieve the access token and user's detail. So that's all for verifying email with OTP verification. Now we can proceed on reset link for forgot password. And for forgot password, we will be implementing using reset token. In our user controller, let's create route for forgot password. For forgot password DTO also, we can include the request token DTO since we are gonna provide email in the request body. Finding user by email will also be the same as requesting OTP. So we can just copy from this. For the reset password functionality, I can use my logic in this email verification where we had included the OTP part. This helps in function reusability. In this generate OTP function, we can return the reset link for forgot password. So in the controller, let's first pass the user and the OTP type. For forgot password, the OTP type would be OTP type.reset link. In case of forgot password, OTP type will hold the reset link value. Instead of generate OTP, we can rename it to generate token. Since this function will now return OTP as well as reset link, I'm gonna change this in email verification part also. So we will now return this OTP only if OTP type contains the OTP. And we are gonna create the functionality of forgot password in this block where the OTP type is reset link. Previously, I mentioned that the token field in the database would store either an OTP or a reset token. However, for reset tokens, we will be using the Jwt sign method, which generates a token with an expiration time. This eliminates the need to store the reset token in the database after saving the secret key. Therefore, the token field will only store OTPs, and we will use the Jwt approach for password resets. Let's go back in our generate token part, then import the Jwt service from NestJS Jwt and inject Jwt service. In the OTP module also, we should import the Jwt module. Then we proceed with generating a Jwt reset token if type is for reset link. For the payload, we are including the user ID and inner. Then we sign it using a secret key. To fetch from .env, we need to also inject config service. The secret key here should be different than that of login Jwt. We can name it Jwt reset secret. As I said earlier, it's effective to store cryptographic key for production and real world projects. But for now, I'm just gonna assign it our demo value, that is demo reset secret key. Here expires in 15M means that the token will be valid for 15 minutes only. After that it will expire and can no longer be used. It can be named reset token instead. Then return the generated reset token. Now it's time to modify the email verification. This part will be common for both OTP type. For OTP, this block will be executed. And in case of reset token, we are gonna create new email DTU. Name it to token. Since we are returning either OTP or reset link, this will also be token now. Let's import our config service. Here we included the reset password URL from the .env file which we will set up. After the query parameter, we append the token generated by the generate token function. This ensures that when the user clicks the link, the token is passed along for validation during the password reset process. So in reset password URL, we should provide the endpoint that will point to the backend controller for verifying the token. In our case, it can be localhost 3000/auth/reset password. So we will also be implementing this reset password in our controller and service. Since we don't have a front end, clicking the link won't directly trigger the API. Instead, the user must extract the token from the URL and send it to our reset password endpoint manually. We will be implementing token validation, but before that, let's complete sending link to email first. The recipients will be the same. Subject can be password reset link, and let's modify the text also. It can simply be click the reset link. Then include the reset link value in the reset password text. Then just call the send email function. So now we have the email verification function completely set for the reset link also. Along with OTP, we implemented configuration for returning reset token and created reset link URL which is sent to the user's email for resetting their password. In the controller for forgot password, we can return message that password reset link has been sent. Please check your email. Now we got to implement verification of token. Before that, let's check whether we are able to get the reset link in the email or not. So start your project. You can see we are getting issue for config service. I guess we forgot to input that in the module. So in app module, just include is global to true inside the config module for root. Now we don't need to keep importing config module in other sub module. Now there is no error and project is successfully started. The route for it will be /user/forgot password. Now I will provide the email of Sarah in post body. If I send this request, you can see we have the reset password sent message. Then let's proceed on Sarah mail, and we also have the new mail. This is the password reset link, and just click on this reset password, and now on the new browser it contains the reset password URL with the token attached. This is the token required for verifying the password reset request. Since we don't have a front end, no page will automatically load. Instead, the token is included in the URL and we will need to manually extract it from here and pass it to the backend for validation before resetting the password. So let's complete the reset password functionality too. In auth controller, this would be post request for reset password. So in body, it will simply be token and password. Let's call the functionality which we will create in our service. Let's also include other function for the verification. We will be retrieving the user ID from Jwt service in this part. I will implement this validate reset password in OTP service part because for the OTP validation also we had used this service. Here we use the Jwt service.verify method to verify and decode the Jwt token that the user had provided. We pass in the token received from the user and use a secret key in which we have stored in our .env file. This secret key ensures that we are using the correct key to verify the token. If the token is valid and unexpired, Jwt service.verify will decode it and return the decoded payload, which typically includes the user ID and email stored when the token was generated. Once the token is verified and decoded, we extract the user ID from the payload of the token, which will be used later in our password reset flow. If the token is expired, the Jwt service.verify method will throw an error with the name token expired error. We can include the message for that. For other error, we can simply give this invalid message. Back in our auth service, this user ID holds the return ID from validate reset password function. In case of no user, we can throw no user found. We can then update the hashed new password to our database. Rename this to new password. Then finally save this. We will return message of password reset success. This part actually contains the user ID, so it should be user ID instead. Then we can fetch the user from repo with the help of user ID. So we have completed the reset part also. Now let's first start the project. And let's also configure the route. So we have the email which we received the reset token. So copy this token part. This mail exceeds 15 minutes. That is, we have set the expiry time to 15 minutes. So this token must be expired, but we can just give it a try. So I'll just copy this token part. In the body, let's include the token with the copied value. And this is the new password we are gonna register for user Sarah. You can see we are getting error for path. I guess we have entered the wrong URL. Yeah, it should be auth instead of user. So now it should work. And you can see the message that token is expired and we must request a new one. So the token should be fresh. So let me go back to the forgot password request. Now let's again request new reset link. And in the mail, you can see we again have the new reset link. So now let me click on reset password again. Then copy this token and we'll simply replace the token with this new one. And now if we send this request, we have the password reset successful message. If we go back to our table and refresh this, we have the new password, but since it's in hash form, we can confirm by logging in with the new password. So let me call login API, and as this account is already verified, we don't need to provide the OTP. Replace this with the newly reset password. You can see we have the token and user info. So this user is successfully logged in with the new password. So that's all for the reset password with reset link. Overall, we have completed the authentication flow, including email OTP verification and password reset. However, this does not fully complete the authentication process. We still need to implement token verification to restrict access to protected routes. This ensures that only authenticated users with a valid token can access certain endpoints. For that, we can use guards. Let's create a guards folder inside the src. In this, we can create Jwt Guard.ts. Guards help enforce authorization logic, ensuring that only authenticated or authorized users can access certain routes. I will first import required dependency for this guard. So the class name would be Jwt Auth Guard, and it implements the can activate. Every guard must implement a can activate function that should return a boolean indicating whether the current request is allowed or not, and this can activate takes context as argument with execution context instance. Now we can access the incoming HTTP request. For that, first we need to switch the context to HTTP and use get request to retrieve the HTTP request object. Next, we extract the authorization header from the request object. This header usually contains the authentication token sent by the client. In case of no token, let's reject the request. If the header is valid, we extract the token by splitting the string at the space and taking the second part, which is the actual token. Now to verify with JWT, let's first inject it. So include this in the constructor. Then this part verifies the token. For secret key, let's import and inject the config service. We can now retrieve the secret key value. If the verification is successful, the decoded user data is attached to the request object. This ensures that only authenticated users with a valid token can access protected routes. This catch block should be below the return part. Then handle exception inside the catch block. And here in the split part, we forgot to provide space inside the single quote. So just provide space here. To use this guard, we need to apply it to the routes that require authentication. So in the auth controller, we can create routes for profile. This would be get request. Let's import our Jwt Auth guard. And we can use the use guards decorator to apply the guard to these routes. And we can access the request object using the request decorator. Then it will simply return message welcome to profile and users info from the request. So let's run our project. Now let's try to access this profile part without providing any token. And you can see we get unauthorized message. So we need to provide token from this user to the headers after bearer. Let's generate this user's JWT and now we can include this token. And if we send this request now, we are able to get the profile route with the details. But you can see we are not able to get its ID. I guess there is some issue in code side. Here it should be decoded.id instead of sub. Now if I again send this request, we are able to get the user ID also. In case of invalid token also, we are unauthorized. So that's all for our authentication flow with validating OTP and managing reset passwords. In this video, we successfully implemented user registration with OTP verification via email, set up login authentication and generated a Jwt token, implemented password reset functionality with token validation, and protected private routes using a Jwt Auth guard to ensure only authenticated users can access them. Thank you guys for watching this video.